Hello, welcome to ANS Solver. This is the fifth question of the paper. So as you can see, this is a Poisson distribution question. So now in 5A part 1, what I need to do is I need the probability of from 2 to 4 inclusive. Okay. So basically I need the probability of x equals to 2 plus the probability of x equals to 3 plus the probability of x equals to 4. So now the formula which I use is simple. It's e raised to minus lambda into lambda raised to x over x factorial. So using this formula, I know my lambda is given to me which is 2.3. So it's e raised to 2.3 into 2.3 raised to 2 over 2 factorial plus e raised to minus 2.3 into 2.3 raised to 3 over 3 factorial plus e raised to minus 2.3 into 2.3 raised to 4 over 4 factorial. Okay, so now I know I need to solve this. So instead of writing this full thing on the calculator, I can tell you a simpler way. So on the calculator, you might be knowing this, but I'm just making sure. So you can click on shift, then click on the log button, which looks something like this. Okay, when you do that, you get something like a summation box with a box here, and something like this. Now, if you see, we are basically summing up from 2 to 4 inclusive, correct? So in the lower limit write 2, in the upper limit write 4. And now here you can write this as e raised to minus your lambda, which is 2.3 into 2.3 raised to x over x factorial. X will basically take all the values from 2 to 4 in the summation inclusive, and to write an x you can simply click on alpha and then click on the closing bracket sign. Okay, so just do that much. Even I'm doing it on the Calc. You'll save a lot of time than writing each and every value down, not only for this sum but for the other sums also. So when you do this, you get your answer as 0.585. Okay, which is basically your final answer of the question. But yeah, you need to write all your steps till this or you won't get marks for your steps. Now, find the probability that the sum of two independent values of x is greater than 2. That means I need the probability that x1 plus x2 is greater than 2. So now the probability of, or the mean, or the lambda of x1 plus x2 will be equal to the lambda of x1 plus the lambda of x2. I know for each of the x values, the lambda is 2.3. So this will be simply 2.3 plus 2.3, which is 4.6. Now I need the probability, okay, of x1 plus x2 to be more than 2. That's basically the probability of 1 minus the probability of I need more than 2. So x1 plus x2 being less than equal to 2. So now I can basically write this as 1 minus the probability of, let's say, x1 plus x2 is given a variable t. Okay, just now for assumption. So this t equals to 0 plus probability of t equals to 1 plus the probability of t equals to 2. Okay, so now I can basically write this as 1 minus I hope you know the formula. It is e raised to minus lambda into lambda raised to x over x factorial. Basic formula. Okay, so using this formula I can write this as e raised to minus 4.6 plus e raised to minus 4.6 into 4.6 plus e raised to minus 4.6 into 4.6 raised to 2 over 2 factorial. Okay, so now I can simply solve this on my calci. Okay, not much to write on the calci, correct? So e raised to minus 4.6 into 4.6 raised to 2 with x factorial. So when I solve this, just give me a moment, I'm solving it on the calci. So yeah, when I solve this on the calci, the value I get is simply 0.837, okay, which is basically the final answer of my question. Now, the random variable s has a sum of 50 independent values of x. Use a suitable approximating distribution to calculate this. Now I know the probability or the lambda of one x value was 2.3. So for one value, my lambda was 2.3. Now there are 50 values. So my lambda will be converted to 50 into 2.3, which basically gives me, if you do 50 into 2.3 in the calci, you get 115. That means my lambda now is 115. Now they have asked us to use a suitable approximating distribution. So you need to know your conditions here. What is the condition of converting a Poisson with a lambda to a normal, where my distribution becomes lambda comma lambda? The condition is that the lambda should be more than 15. Okay, this is the important condition you need to know. Okay, and they're all, when you convert this, there will be something called as a continuity correction. Okay, now if you see your lambda, it's more than 15 because it's 115. So I can say this can be approximated to my normal with 115 comma 115, because in a normal this is the distribution, correct, and your lambda is basically your mean and variance both, correct, you know that. Now I need the probability of s to be less than equal to 110. Okay, so let's say this is my normal distribution curve. I have my mean, which is 115, because this is basically mean comma my variance. Okay, so let's say this is 115 and 110 lies here. I need this to be less than 110, which basically lies somewhere here. Okay, so now what I basically need is, I know I need to calculate my z, which is my value minus the mean over the standard deviation. But here, because we are dealing with Poisson, the mean and standard deviation will go, and I have a lambda and a root of lambda, because I know root of variance is this standard deviation. But now, what will be the value? Is it 115? No, wrong. I told you that there's a continuity correction here. It basically means, if you might be doing this from AS, if this is less than equal to, the continuity correction is basically 115 plus 0.5, correct, in when you do normal Poisson, correct, Poisson to normal. So that time I get this as 115.5. okay, this plus 0.5 is called the continuity correction. Okay, so you need to know this, it's a very important thing. So this I get basically as z equals to 115.5 minus, actually sorry, my bad, the continuity correction is not added to 115, it will be added to 110. Sorry, my bad, because 110 is your value. So now you basically write this as 110.5. Okay, So now I'll basically write this as 110.5 minus 115. Okay, sorry, I didn't do it properly. So with the square root of 115. So my z is basically equal to 110.5 minus 115. Okay, with the root of 115. So when I solve this, I get my value as 0.419. So I'm just, again saying sorry, because this is actually the test value, not the test value, sorry, the value you need to add the continuity correction to, not the mean. Okay, not the mean, only the value. Okay, so now what I simply do is I can go on the calculator. So on the calc, I need, basically because I need less than, I know I need the phi of minus 0.419. Okay, because phi means less than. So what I can do is on the calculator, I can simply go to the mode, then I can click on 3 where stat is written. Okay, then I can go to AC, then I can click on shift, then I can click on 1, then I can click on 5 where distribution is written. Now when I click on 5, I'll get my display as 1.p, 2q, 3r and 4t. Option 2 and 4 are not that important. I need to know 1 and 3. 1 basically means less than, which basically means the phi, and 3 means more than. Here I need less than because of the phi, so I click on option 1. When I click basically on option 1, okay, I get this as p with a bracket. So in the bracket, I simply write minus 0.419. Okay, so when I do that, I basically get my answer, and when I click on equal to, I get my answer on 0.337. So just mentioning it again, the continuity correction is added only to the test, or only to the value, not to the mean. Okay, really important. Now the random variable y has a Poisson distribution with some lambda, and I know p of y equals to 3 equals to p of y equals to 5. So now I know my formula is e raised to minus lambda into lambda raised to x over x factorial. So I can simply write this as, because I know p of y equals to 3 is equal to p of y equals to 5, I can simply write this as e raised to minus lambda into lambda raised to 3 over 3 factorial equals to e raised to minus lambda into lambda raised to 5 over 5 factorial. Now I can simply cut this off, correct? So now I can write this basically as 5 factorial over 3 factorial equals to the lambda raised to 5 over the lambda raised to 3. Now 5 factorial basically means 5 into 4 into 3 into 2 into 1 over 3 factorial means 3 into 2 into 1, which is equal to, I know this can be written as lambda raised to 5 minus 3. So now I can simply cut 3, 3, 2, 2 and 1, 1 here. So 5 into 4 I know is 20, which is equal to the lambda raised to 5 minus 3, which is 2, which I can write as lambda equals to the root of 20. Lambda can never be negative, so my lambda is basically equal to root 20 only the positive, okay, not the plus minus. So the value I get is simply 4.47, which is the answer for lambda.